and so on,
Yeah, what
which is
I did
quite a bit
in
of work.
class was just put in the calculator.
Okay.
So
And
what
that's,
I just put it into
and
the calculator and then put graph and then calculate the zeros on the
okay,
left,
so
right.
what zeros did you find for this?
Let me grab this quickly. The zeros, I got -2, -1 with a multiplicity of 2, and then plus, or actually, never mind, that was the notes. Never mind, wrong thing. Let me grab the homework. Oh, here it is. I got x equals -4 and x equals -2.
Okay, anything else? I mean, that's only two. There's four total roots.
Mm.
So those are both double roots.
Yeah, the multiplicity of, oh yeah,
Okay.
multiplicity of 2 is what I
Yeah,
said.
so when someone asks you for the zeros, another way to do it is to just list them, and then it's also clear. Okay. The next thing is to write it in factored form, which
I did that.
shouldn't be too bad. So it should be like x plus 4 squared, x plus 2 squared. Notice it doesn't say linear factors, so this is
Yeah,
acceptable.
yeah, that's exactly what I got.
All right, and then part C is this graphing thing. So you need to know the end behavior to be able to graph it as well. What is the end behavior of this? Like what?
As x goes to positive infinity, f of x goes to positive infinity, and as x goes to negative infinity, f of x goes to negative infinity. And positive,
It's
positive,
positive.
positive.
Okay,
Yeah.
yeah, all right. So we know it touches at -4, it touches at 2, and it it does this. Now you could also find the y-intercept. What would the y-intercept be in this problem?
The y-intercept 64. 0, 64, yeah.
Yes. Okay. And I don't know how we're going to show that on here, but I mean, I guess you can just say, there it
Yeah.
is, 0, 0, 64. So it comes down, hits, hits, comes back up, and then, because it's not scale, doesn't look right. But I mean,
Yeah.
it basically goes up forever.
Yeah. What we did in class is we basically like found the maximum and minimum on the calculator, then graphed all the real zeros and then the maximum minimum and then graphed it like that. So pretty much the same thing, just we just found the
So
behavior.
the local max and mins are going to be here in red. There's that one, that one, and that one. And then the only way to label those, because you don't have any calculus at this point, is
It's
to,
absolute or relative.
yeah, these are relatives, all relatives, but
Actually,
you
wouldn't the -4, -2 be absolute?
they actually are classified as both. Um, so your teacher is disguising it because you haven't learned enough, but and you need another course or two. But they are absolute mins. They're also relative min. So the absolute min is 0, uh, x equals -4 and -2. The relative max is 1 at x equals -3. The only way to get that is from graphing it on a calculator. I don't know how else you would be expected to do that.
Yeah, I think that what we did in class, we put the equation to the calculator, got the graph, and then, did the whole second trace, and then found the
Okay.
minimum and maximum that way.
It's not clear if, like, whether you're allowed to use a calculator for all of this or some of it,
Yeah.
or
So what she did with our chapter this time is like everything we're doing right now, 4.10 and after, there's calculator allowed, and anything we did before that was like 4 point like 9, 8, like all that stuff, that's all no calculator. So we had a test that was no calculator, like all no calculator, and this upcoming test will be all calculator. Like you're allowed to use the calculator for all of them. So
right?
yeah,
Well, yeah,
we
I mean, you have
will
to keep that for the test. You're gonna have probably two parts, or you're gonna have, it'll say calculator or no calculator, show your work or not. So now to answer this question, uh, the function is greater than zero when it's above the x-axis, and then where it's below the x-axis. So you're basically just going back to your graph and deciding where is it above, where is it below. Notice it's never below, but you do exclude the place where it touches because that's exactly equal to zero. So
yeah, since both of them don't say greater than or equal to or less than or equal to, then you wouldn't
right,
count it because
right. So the answer here is where f of x is greater than zero, and it starts from left to right, minus infinity to -4, -4 to -2, and then -2 to infinity. And then, you can decide if you need union or if commas are okay. It depends on the
I think
class
for
and the
our
teacher.
teacher, she wants us to put a union in the middle of between
Okay.
like every two of them. So all right, whatever. Yeah, so so then you would put f of x, and f of x is greater, or yeah, greater than zero,
And then f of x less than zero is
or less than zero. Yeah,
nothing. You can either if so there's a couple ways to do it. There's
zero.
empty set. There's you can actually use curly braces to show the set that's empty. You can say, does not exist.
How, wait, how come we can't put like zero as an expression, none?
Zero is not the same as nothing. It's because these are actually sets. These intervals are really representative sets,
Got it. So
and
we
zero
just
is
put
not
doesn't
a,
exist.
yeah.
And then for E, it says find the intervals where f of x is increasing, where f of x is decreasing.
Yeah, so
So,
increasing means going up and to the right, and then decreasing is down and to the
so,
right.
so increasing would be like from -2 to positive infinity, and from -4 to -3.
Let me look at it one more time here. Yeah, and you do it left to right. So -4 to -3, and -2 to infinity.
And then for the decreasing would be negative infinity to -4. And
Yeah.
yeah, -3, -2. Got All right, moving on to number 2.
Do you want us to move to number 2 or go to
Yeah,
one of the backwards problems? At number
let's
2.
start it. Yeah,
All right, so this can be done by hand with some factoring. Uh, so don't know if that's what your teacher expects. I know you said calculator, but this can actually be done by hand. Um, you get x could be 0, or x is plus or minus the square root of 7. And that's between 2 and 3 on your number line. Square root of 4, square root of 9. Um, that's how you do this without a calculator.
Got it.
All right. So the factored form, which is kind of what we did. I don't think your teacher wants, well, I don't know what they want, but you could write it as like we had there minus x, x squared minus 7. I think you could also write as x minus square root of 7, x plus square root of 7. You might check this to see if that's, which one they want.
Got it.
All right, so the graph here, uh, you need to know the degree and then the end behavior, so you can sort of get a feel for what's going on when you graph it here.
Let's see here.
So it's degree 3, and the leading coefficient is negative. So it starts high and ends low. And it's got a 0 at, like I said, minus 2.5, positive 2.5, and then 0. And the degree of, or the multiplicity of each of these is 1. So we know that it crosses at each of them. Something like that.
Yeah. She did say that she just wants us to do the maximum and minimum so that we have an she just wants us to have an accurate graph. So he said that she wants us to find the maximum and minimum points, graph those, and then and then draw like the graph through
Okay.
those points.
Yeah, so,
So
you have to do that on your calculator, and you're right. Like it's actually much further down. On those, it's down here at minus 7-ish. 1, 2, 3, 4, 5, 6, 7. I think it's an odd function, so I think it's with the same place. Yeah.
relative min.
So this is a minus 1.528 comma 7.128. 1.528 comma 7.128.
Got it. And she just wants us to kind of round it to the nearest. And there's so negative 2, -7. Okay. -2, -1, 2, 3. Wait. All right, I drew my graph.
Right. And so
Yeah.
you've got those local mins and maxes. Then I think the next one's where f of x is greater than 0 and less than 0.
Yeah. Or yeah, in this case, g of x is
G of
greater
x.
than 0 is greater than 0 is negative infinity to -3 union, and then 0 to 3, and then g of x is less than 0 from -3 to 0, and from 3 to positive infinity. All right. Then find the intervals where. Oh wait, that was the. Find the intervals where g of x is increasing, where g of x is decreasing. G of x is decreasing from negative infinity to -2 union from 2 to positive infinity. So from -2 to 2. All right.
All right. Any questions on that? Thoughts on that?
No, I think I get it.
All right. Yeah, really everything from the graph is key there to doing this. All right, you ready to move on to number three?
Yeah.
All right, so for number three, the first thing is to determine the roots or the zeros and then their multiplicities. And you really want to do it from left to right. So it's -4, multiplicity of 1, -2, multiplicity of 1, 3, multiplicity of 2. And then you start by writing it in factored form. So that's part A. It's A x plus 4, x plus 2, x minus 3 squared, like that. And then you need to find A. To find A, you use the y-intercept.
Couldn't you also use any point on the
Yeah,
table?
yeah,
Or not
but
the group or the
yeah,
graph,
but
I
but
guess.
you got to be like, which one are you going to use? Like, I mean, hey, how are you sure that that's like exact? I
Yeah,
mean,
yeah, because it's not on a ticked graph like the ones
yeah,
above it.
there's no grid.
Yeah, so in this case it'd be 0, 3.
Okay,
Uh,
so when x is 0, y is 3, or f of x is 3. So you're going to put in 3 equals A, 0 plus 4, 0 plus 2, 0 minus 3 squared. So 4 times 2 times 9 ends up being 72A. Divide both sides by 72, so A equals 1 over 24, and that has to go back into, it's right here. So f of x equals 1 over 24, x plus 4, x plus 2, x minus 3 squared. Now, you should ask your instructor if you are concerned. It doesn't say to write it in factored form or standard form. You should ask if this is okay. I mean, I think it is, but yeah, that's up to you.
yeah, and
All
the
right.
intervals that it's decreasing would just be from -infinity to
So
-3.
yeah, this is part B, -infinity to -3.
Then yeah, 0 to 3.
So for part C though, there are two things that have to be true, right? It has to be above the x-axis and going up and to the right. So
Got it.
give me that. Give me those. And they're interval or intervals, or might be more than one.
Um, from -2 to 0,
Okay, agreed.
-2 to 0, and then from 3 to positive infinity.
I agree.
Identify any absolute. Oh, this is the one we're supposed to identify the maximum.
Yeah. Now the with the maximum min there in D, you do have to evaluate for f of -3. I mean, I assume that's where it is. That's for, well, oh, no, okay, I see. You're not actually doing, well, you are doing relative. So yeah, you're gonna have to do it at these, but the other ones are very, very clear. Like f of 0 is 3 and f of 3 is 0, but f of -3 is a bit of an unknown. You have to go back to the equation and evaluate it.
Minimum. It Yeah, it's -3 comma negative like -1.5.
That's what it looks like on the graph. -3/2.
That's the absolute minimum. -3 halves. Then the maximum. So this would be the relative maximum.
Yeah, so the first one is a relative min on the left here. This is a relative max.
Wait, wouldn't that be a absolute max? Those two would be absolute, and then
Yeah,
the middle one would be.
they can actually be both, but the if it's a what's called a critical point, which you'll learn in another course, it's always a relative, but then it could be an absolute.
All right. All right. So moving to number 4.
Okay, so kind of the same type of thing. You've got they've already found uh they've already found
And then the
the
domain is
function.
kind of given, but it's
Domain is always, yeah, all
negative
real
infinity.
numbers. And
Yeah.
for a polynomial, you might just commit that to memory.
Find the zero. Okay, so
The range, though, is where the mins and maxes come into play. Your
yeah.
teacher's been a little deceptive here. The graph goes on forever, but we need to figure out this point down here, which appears that you have to evaluate the function at f of -2. I mean, I guess you could also graph this thing and use your tracing tool to find those points. I'm not really sure what to suggest what's best because it depends on what you're most comfortable doing.
Um, I was just doing the second calc 0, but I was trying to find it for this third 0. Wait, let me just see what I was going back to 4. Yeah, I think I found it. So I got x equals -3, -0.5, and 4.
Right. Well, those are given though from the function. I mean that's going to be a given from the function. But these, mins and maxes, they're the ones you're going to have to find.
Yeah. Which find the intervals on which g of x equals 0. Oh, g of x is less than or equal to 0. Right. Wait.
So that's where you got to identify these critical points.
Oh, wait,
The
actually, I think
mins.
it would be -4 as one of the zeros, not -3.
Yeah, sorry about that. No, it's in the function. The function is
Huh.
talking about number four, right?
Yeah.
So I mean it's -3, -0.5, and 4.
All right. Uh, oh yeah, it's up there. Yeah, to show it's not. So this would be from intervals would be from 3, including 3, to -0.5, including -0.5, and
That's
that
good. Yep.
would be it.
Make
Yeah,
sure you use the bracket
yeah,
notation
the
for it.
brackets. And then so when it's over, on which x of g of x is zero is greater than 0 and increasing. So that's the increasing.
Now
So
there's also this point over here at 4 to include. I don't know if you got that.
um oh yeah, because it's included. Yeah, I see that. It's technically still on the 0, so got it. And then which g of x is greater than 0, so it'd be -0.5 to 4, 4, including -1, and then 4 to positive infinity. All right. Uh, yeah. All right. And then find the intervals on which g of x is decreasing.
Okay. Means it's going down and to the right.
So that's -infinity to, uh, oh, yeah, you find the minimum now.
So that I've already got that in the graph here, but it's at -2 is the x value.
So -infinity to -2, and
Yeah,
then from +2 to 4.
got it.
Right.
And so there is for part F, there is, there is an absolute min. There's a relative max and then a relative min. And
Abs so the relative min, or the absolute min, absolute minimum would be 2, -11.25. The relative min would be 4, 7, oh, actually just 0. Relative min would be 4 comma 0. Then the relative mat would be 1.37 comma 11 point.
Any questions on that before we move on to number 5?
No.
Okay. Five's pretty challenging because of the overlapping graphs. There's just a lot going on there. So for k of x, it's almost like you want to just look at only that, but you got to find the zeros and the so let's see here. So k of x has a 0 at -1, so that's x plus 1. That's right there in black. It's squared because it touches, and then look like x minus 3 for that other one at 3. And then to find the a value, you've got to put 0 in for x, and it looks like it has a y-intercept of -3. Which makes a equal to 1, it looks like.
Got it. So then it would be k of x equals just x plus 1 squared
Yep,
and
x
x
minus
minus
3.
3.
Yeah. Now the next question, B, is pretty heavily influenced by the graph. Just looking at the graph, it doesn't have anything to do with the functions. Um, so I think it's helpful, at least in my world, I can grab the graph again. So R of x is below the x-axis. So it's almost like you want to like highlight that where it's below. And then K of x is above the x-axis. So is there any region there where K of x is above the x-axis? Well, actually, and equal to. Boy, that's also frustrating. Okay, so it looks like right there is the only place it's also true. On the right here, where I'm highlighting, that's the only place where both appear to be true.
Alright.
So that would be from 3 to infinity. These are pretty tough because you got to really be confident that you're, got both selected. Okay. The next one here where they're both decreasing, so they're both going down and to the right. So you want to basically just start with one or the other. Doesn't really matter. I'm just going to pick R because it's the first one. So it's decreasing here, and then it's decreasing, and then you're trying to figure out in just those intervals, is the other one also decreasing? So in this first interval here, the green is going up and to the right, so that one doesn't work. Here, here it looks like it is not, it's really hard to tell, but it looks like they both have the same place. So I don't see anywhere that this is both true. None or DNE. Oops, I'm sorry. You know what? I apologize. I'm giving you the wrong information. Let's reset here. I misread this. R of X greater than 0. Oops. Okay. R of X greater than 0 is here and here. And then K of X decreasing. So that means the other one's going down and to the right. So it looks like it's going down and to the right here. So that's the only place where they're both true. Looks like that's from 0 to like 1.5. Because in this other red region, the graph's going up, so it's definitely not decreasing. It's actually a really good question, especially for like calculus students. Um, is that okay?
Yeah.
All right, and then you already know I did part D for the local max and mins of R of X. Looks like you got a local min, a local max, and another local min, which happens to be an absolute min there. Let me know when you're ready for us to move on to 6.
All right, yeah. Okay.
So let's see your possible formula for f of x. I guess f of x is the green one. So we got x plus 2 to the power of 3, x minus 1. And then a, we know that at 0, it goes through 0, 8. And so that'll end up being a -1 out in front. You can check those steps later. G of x, same deal here. I think we actually had a problem just like this earlier, maybe just shift it over a little bit. You got x minus 1 squared, x plus 1 squared, and the a ends up being 1 because it goes through 0, 1. And that's kind of the speed your instructor expects you to do it, kind of as you go rather than trying to make a table. And
Got it.
okay, so greater than 0 means it's above the x-axis, which is basically everywhere on g of x, except for those two places where it touches. And then the other one is increasing. It's increasing everywhere except for uh, this point over here on the right, which I don't know if you have to find. I guess you probably do, um, which means you have to graph it, but you're supposed to use the graph. So I don't know, you're supposed to sort of estimate that point there as well. So g of x, the only place it's going to be excluded is at the -1 where it touches. But f of x is increasing from -infinity to -2, but it does not include -2. And so then you're going to the right and you get to that point, you're like, okay, well that's excluded at -1. And then -1 to whatever the x value is up here at this dot, where it's not really, maybe it's like, I don't know, 0.3. We don't really know.
Got it.
So now the last one here, where the f of x is greater than 0, so where the green one is above the x-axis, so all this place are above the x-axis, but the other function has to be decreasing. So you can see it's decreasing for sure as soon as it crosses there. As soon as it crosses at -2, it is decreasing all the way to -1. But then it doesn't start decreasing it until this point, and this one is above the axis. So we got another kind of situation where it's like, all right, well, I guess it's about 0.3 to 1. Your teacher probably should have asked part E first. Um, because that is kind of important. Like normally you would break these up into intervals and see where they overlap, but you're trying to do it visually with the graph. So F is increasing everywhere except there. There's actually a horizontal tangent there at -2 all the way up to this point. So -infinity to -2, union -2 to like 0.3, something like that.
Got it.
So maxes, mins of g of x. So it looks like there's absolute min -1 and 1, and then a relative max is at 0. That's the black graph there.
Got it.
All right. Good job. Okay. Anything else you want us to cover today?
No.
All right. Well, thank you for letting me push back our lesson a little bit. We'll be back on our normal